Assalamualaikum. We are from Group 7. Today we would like to present an experiment which is momentum and energy. Our group consists of 3 members, which is me, Nurul Adlina, Nur Fatin Najah, and Nur Farhana. The objective from the experiment of momentum and energy is to determine the velocity of a horizontally projected object, a metal ball, fired from a spring gun. The laws of conservation of energy and momentum are among the most fundamental and useful laws of physics. They aid in the solution of many mechanical problems and come up frequently in many fields of science. What this law means is that if a system does not have net powers, then at all times the system will have the same momentum P equal to mv, product of a system mass multiplied by its velocity. Furthermore, if there are no external or internal forces working in or on a system, then the system energy will remain constant. In these conservation rules, Newton's first law is concealed. Newton's first law states that as long as no forces act upon them, bodies at rest will remain at rest, and bodies in motion will remain in motion as long as no forces act upon them. If one can see, Newton's first law is a declaration of momentum and energy conservation. Stuff as long as they are left alone remain the same. Before electronic timing devices were developed, the ballistic pendulum was used to calculate the speeds of bullets. Since real bullets are not practical to be used in an introductory physics lab, therefore the staple bullet from the staple gun is a reasonable replacement, and this experiment can be set up.
For the presentation. Next, I'm Fatina Mahadi will present to you the apparatus that we will use in this experiment. The apparatus that will be used is meter rule, meter ball, pendulum, and spring gun. For the procedure of this experiment, first step is the mass of meter ball and mass of the pendulum was measured. Second step, the height of H1 was recorded by using meter rule. The height of H1 was fixed as 75 cm. Third, the distance from table to the center of the pendulum ring was measured by using a meter rule. A small red dot marks the center of the pendulum ring. Fourth step, the ball of the gun and push it was placed against the spring back to the second or third detent position. The same position of the spring gun was used for all data. Fifth step, the metal ball was fired into the ring and distance from the table to the center of the pendulum ring when the pendulum combination is stopped at its highest peak was measured. Sixth step, data was recorded in table 1. Seventh step, step 1 until 6 was repeated at least for 9 trials. This is an example on how the experiment was done. While we observe this experiment, we can see that this experiment can be conducted in many ways. So today we would like to show you on how the experiment can be done.
Thank you to my friends. So next we'll go to the data and the results of this experiment. My name is Nur Farhana binti Mama Fauzi. I'll be explaining about the data and the calculation for this experiment. So as you can see here, the table below shows the data and result for this experiment. 9 trials were taken for this experiment for the accuracy of the data. And then after that we calculated the value for the H1. So the value for H1 were fixed for the 9 trial, which is 75. And then we calculated the H2. Then H, to calculate the H, we will subtract H2 with H1. So we get the value for every H. And then after that we can calculate the U. So, formula for U is which is the velocity of the ball is m capital plus m over m square root 2 gh. So, from this formula, we can calculate every value of U for every trial. So we are done here. We will get the value of U. Next, we will proceed to the calculation. So from the table, we get the value of U, which is 5.7549. So here we will calculate the uncertainty of U. So the formula given is delta U over U equal to delta M plus M capital over M plus M capital plus delta M over M plus delta H over H. So the formula was delta U over U. So the U will be shifted to the right. So the formula will be calculated with U getting multiplied with the formula. And the value we will get is 0.3177. So the final value for U will written with the uncertainty is U plus minus delta U equal to the previous value of U we calculated from the table, set 5.7549 plus minus with the uncertainty that we calculated 0.3177. So we are done with the value of U. We will next move to the percentage error. So the percentage error will take the value of the trial from the first trial with the last trial. We will go with 5.844 minus 5.755, which is the ninth trial and the first trial, over with 5.844 times with 5.755. So this value will be multiplied with 100 for the percentage error. So we will get with 0.265%, the value for the percentage error. So that's all from me, I guess. Thank you.
Thank you, Farhana, for the explanation. Next, for the conclusion. The velocity of a horizontally projected metal ball fired from a spring gun is 5.7549 with uncertainty 0.3177. The experiment is successful and there is an error which is parallax error. So, make sure eyes are always perpendicular to the scale of the meter when taking the reading. This is how the precaution we can take to avoid the parallax error. Our eyes must be perpendicular to the scale. For example, we can see the correct position is 4.8 cm, which is the position that perpendicular to the meter rule. That's all from us. Thank you.